All right, so welcome everybody who's joining us on YouTube. It is April 1st, and we are thinking about the chain rule right now. So I talked with the people who are here for a few minutes at the beginning of class, and we're going through activity 2.5.2 in active calculus. And so this is part D of that activity. And what we want to do is we're going to think through this and sort of how we would take the derivative of this function. And so what we're seeing right here is this 5 right here is a little bit confusing when we have exponents on trig functions. So what I would do when I think about this is I would rewrite, okay, I'm gonna rewrite this and say, instead of using this notation, I'm gonna introduce a set of parentheses and I'm going to rewrite my function like this. Okay, so now when I rewrite it like this, it helps me see that I have an inside function and I have an outside function. Okay, so my inside function here is going to be my cotangent, and then my outside function is going to be this out here, right? So this is my something to the 5th power. That would be my outside function. All right, so if you view it this way, I think it's a lot easier to identify, hey, what's your inside function, what's your outside function? And so the way that we've been handling this is we would say f of x is our outside function, so that's going to be x to the 5th power. G of x is going to be our inside function, which is cotangent. Okay. And all right, so in order to take this derivative, I'm also going to need to know what f prime is and what g prime is. So the derivative of x to the 5th, we're going to use our power rule, so that's 5x to the 4th, and then g prime of x, right? So derivative of cotangent is negative cosecant squared. Okay. So far, so good for everybody? So Sam, does this help so far, viewing it this way with bringing that exponent out and making explicitly you have this outside function that's x to the 5th? Yeah, all right. Okay, so to finish this off, what we're going to do is we use all of this information. So I'm going to use a chain rule. So it's the derivative of the outside, right? So it's f prime of g of x, right? So this is f prime, but we want to plug into it. We want to plug in g of x, so it's going to be, right, 5 cotangent x to the 4th, and then we're going to multiply by g prime, and so we're going to multiply by negative cosecant squared here. Okay, so all my work I put sort of in the middle here, but the derivative, right? So the answer, the derivative of cotangent to the 5th is going to be 5 cotangent x to the 4th times the derivative of cotangent, which is negative cosecant squared of x. Okay, so another example of chain rule. Okay, still good? We're still good out there? Yeah, good. A head nod, thumbs up. Okay. All right, so looking at 2.5.2, these others are pretty good for us. Breaking it down, figuring out what the outside function is, what the inside function is. All right, Amber gives me a thumbs up. All right, so when we look at this one, activity 2.5.2, it is sort of base level chain rule. So the only rule that you're applying in activity 2.5.2 is only chain rule. Okay, so there's no other rules that we're going to be applying. We're not multiplying any functions together in there. We're not, I guess we're adding in one spot. But sometimes what we're going to find as we move on here is we're going to have to start putting multiple rules together. And when we do that, we're going to have to identify the structure of our functions. And so if I give you a function like this, let's say f of x is 2 raised to the cosine x times the square root of sine of x. Okay, so if I have this function here, and I want to take the derivative, what would I do? When I look at this, I ask myself, hey, I need to think about what rules I have, how this is made up, and what order I'm going to have to do those rules in. So, any ideas here so far? Sort of what we would do. Yeah, so you're gonna have to use chain rule and product rule. And so when I look at this, when I see chain rule and product rule, the first thing I see, right, is I see there's a product here, right? So I'm multiplying this function times this function. And I also see chain rule in here, right? So I see chain rule because I have a function composition for this one, and I also have a function composition for this one. So when I look at this, I'm gonna have to decide, yeah, I see a product, and I also see a composition. So those are the two rules I'm going to use, like Emily puts in the chat. But what order do I do them in? Do I do a product first, or do I do a chain rule first? What do y'all think? That's right. Yeah. So the way Luke said it is exactly right. So you think about this as, hey, what's happening first? What's sort of the outside structure of your function? And the way Luke put it, he says chain is inside of the product, right? So this composition that's happening right here, it's inside of the product. So you can think about this as on the outside, the first thing that we're doing is we're multiplying these two together. And then inside of that product, we have a chain rule. So we're going to have to use chain rule second. Okay, so when I set this up, the first thing I'm going to do is I'm going to take the derivative with this as the product. And so what I get is, so I'm going to space this appropriately here. Right, so I like to set up my framework. I'm going to say, okay, so what I need is I'm going to have to take the derivative of some of these pieces, and some of them I'm going to leave alone. So I take my first function. Okay, so I'm going to have this first function right here. That's going to be left alone, right? So I have 2 to the cosine x. And then I'm going to have to multiply over here, right? So this is going to be the derivative of square root of sine x. Okay. And then, so that's where I'm going to have to use chain rule. And then over here, I'm going to have to take the derivative of my first part, and then I leave my second part alone, right? So we're going to have over here square root of sine x. Okay, so I actually haven't taken any derivatives yet. I've set up my product rule framework. And then what I know is in this spot right here, okay, so in our first spot, I need to have right, so this is going to be the derivative of square root of sine x. That has to go here, and over here, I need the derivative of 2 to the cosine x. Okay, so in this first part, I now have broken this down where I'm going to set up my framework. So I've already taken care of product rule. Everything is in there. And now, in order to go a step further, I need to figure out what these derivatives are. Okay, so at this point, what I'm going to do is I'm not going to write out the function. So since there's so many rules happening here, I'm gonna rely on sort of my understanding, my familiarity with chain rule to go through instead of, so if I go back one slide, what we did over here when we did chain rules, we broke it down into the 4 pieces. If you want to do that, you can. I think it's going to be to your benefit to actually to not have to do that. So if you can start doing chain rule without writing those out, you'll be, I think, in my opinion, you'll be in a little bit better shape because things are going to get pretty messy when you have lots of, say, F's and G's floating around for these things. So going down a step further, right, so this is 2 cosine x. I'm going to take the derivative of square root of sine x. So I take the square root and we can write it as the 1/2 power. So using our power rule, we're going to get 1/2 sine x to the negative 1/2, right? And then, so this is our f prime of g of x. And then I'm going to multiply by the derivative of sine, which is cosine. Okay. So this is my derivative of square root of sine x that goes into this spot. And now I need to take the derivative of 2 to the cosine x. So the derivative of my outside function is an exponential. So I'm going to get 2 to the cosine x times natural log of 2, right? So this is my f prime of g of x. I'm going to multiply by the derivative of cosine, which is negative sine x. Okay, and I'm running out of space here. And so then my square root of sine x is going to come down here. So let's see if we can do this over. Okay, so square root of sine x is going to go in over here. Okay, and then or resize. Okay, so there's really a lot that's happening inside of this. So I want to take a minute, pause, and see if there's any steps in here that are not clear.
Is the cosine x there because of chain rule, or is it there because of product rule?
So this one,
Yeah.
that's there because of chain rule. So if we think about this, so chain rule is so we're gonna have to excuse our notation here. So let me back up. So let's not call this f. Let's call this function p of x or something. So it's different. Okay, so this part right here, this would be our f prime of g of x. And then this would be our g prime of x. If we're thinking about our usual notation for our chain rule. Okay, so we have our outside function, right? So our outside function is going to be this 1/2, right? This is the square root, right? So the square root's our outside function. So you get 1/2 something to the negative 1/2. That's our f prime. The g of x stays put, right? So this is the same sine of x that goes in here. And then we multiply by the derivative of sine x on the outside. Yeah. All right. Other questions, comments, concerns about this part? All right, so what I want to do, I'm going to minimize this and bring back up our, right, so we're going to bring back up our book here. So there's 5 examples, A, B, C, D, E. You can see them right here in section in 2.5.3. So these are all rules that what we're going to do is we're going to be thinking about there's multiple rules that have to be applied here. So when you look at this, when you take this derivative, you're going to have to use a few different rules. When you look at this derivative, you're going to have to use a few different rules. So what I want to do is I'm going to put us into breakout rooms. So you all have a few minutes to chat with each other and then try to think through these 5, right? See if you can do them. And so we got a question from Luke that just came in. So Luke, yeah, this negative sine x, is this the one you're talking about over here? Yeah, so that's the same thing. So when we do what we're doing here, when we break this down with chain rule, again, this is our f prime of g of x. So our outside function is the 2 to some power, right? 2 to the x. So this is the derivative of an exponential, right? 2 to the input times natural log of 2. And then we're multiplying by the derivative of that inside function, right? So this is G prime again. So excuse the notation here. So these F's and G's are different, right? So this is just pointing out that this is the notation for our chain rule, right? So this F and this F are different functions. Okay. All right. So let's bring this back up. Oh, it goes down to the bottom every time. But I want to think through these 5, right? So I'll put you into breakout rooms. It'll be, so there's 8 people here. So we'll do 4 and 4. I'll just do 2 breakout rooms today. And then we'll come back together, say, in 10 minutes or so. So I'll give you 10 minutes to think through these 5. So I'll open these up. So you can go ahead and go in these rooms, think through the 5 of them, and then I'll kind of float back and forth between the 2.
Luke, your mic is kind of scratchy.
Whenever I have my earbuds in. So it's
Yeah.
weird.
Yeah, I can't really hear you that well.
It's because he has his earbuds in.
Can you hear him?
It's kind of scratchy for me too, yeah.
Yeah.
But we got the chat too.
Alrighty.
All right, so how did that go? These ones are a little bit more challenging, right? Lots of moving parts. So any questions so far about that last one, or getting into this stuff?
Yeah.
So I think it might be helpful to bring up like a Desmos window. So remember I showed us before the we can typeset some of these things in a Desmos window. So if I bring this up, so I'm going to go ahead and I'll show you what I'm saying here. So if I bring up a Desmos window, something like this, right, then we can sort of put in our functions here. So if I'm sort of talking through it, my function P of R is 4 square root of R to the 6 plus 2e to the R, right? So it gives me a way to typeset. And if you all want to annotate, you could actually, right? So if I click on my annotate, I could actually like draw over here if I wanted to. Right, so it kind of gives us a nice way to do things. So if we want to, we can walk through this one together, and then I'll kick it over to, I don't know, who's on a laptop? Caleb, are you on a laptop?
Yeah.
Okay, so when I jump over to the other room, I don't know if you want to go ahead and maybe do the same thing that I'm doing here, bring up Desmos and then
Sure.
share your screen so you can typeset it. All right, so what are you all thinking when you take this derivative?
Gonna use chain rule.
Mm-hmm. And so what's your inside function? What's your outside function?
Inside function would be R to the 6 plus 2e to the R.
Yeah, right. So
Outside
this would be
would
R to
be-
the 6 plus 2e to the R. That's your inside function. And then your outside function is this square root. So so what I would do is I would actually rewrite this as 4 square root, or not, I wouldn't use square root. I would rewrite the square root like this to the 1/2 power. And then inside of here, we're going to have R to the 6 plus 2e to the R, right? So what I would do is I would be I would be viewing my function like this way, right? So I would be viewing it like this. And then when I take the derivative, what I'm thinking about is I'm sort of covering this up, right? So the first thing that I'm imagining is, hey, I'm looking like in my mind, this is what I'm visualizing. I have 4 times something, right? We don't know what goes in here. It's 4 times something to the 1/2 power. And when I take this derivative, right, what I'm going to do is it's going to be, you know, the 4 comes down for free, and I'm going to have 1/2 times whatever this is raised to the negative 1/2. So something like this. Okay, so as I'm breaking it down in my mind, this is sort of the way that I'm thinking about it. Okay, so 4 times 1/2 to the negative 1/2. This is the derivative of my outside function. And then inside of here, what I need to do is I need to plug this in, right? So we're gonna have something that looks like this. And then what I need to do is out here, I need to multiply by the derivative, right, of my inside function. So as I'm breaking this down, like I'm stream of consciousness thinking through this one with you all, so you can see sort of how I'm breaking this down. And then what's going to go over here is I'm going to have the derivative, right? So the derivative of this, we're going to take the derivative of each piece separately. Okay, so this one, r to the 6th, I'm going to use power rule, and then 2e to the r, I'm going to use my exponential rule. So we would get 6r to the 5th plus 2e to the r. Okay. So if we want to, we could then go ahead and actually check this, right? So Desmos will allow us to use x here, right? So if I think about this, the function that I just typed in as the derivative is this green line right here. And then when I ask Desmos to graph the derivative of p, we can see that they're the same thing, right? So that gives us a way to verify our answer here. So what do y'all think?
Looks good.
Okay. So so this typesetting, does this work out for you? I mean, this is one way where I know sharing these derivatives is really a super challenging thing for us at this time. And from what I've seen, this is sort of the best of the options we have for typesetting math. Amber, you hanging in there?
Yeah, I'm good.
Okay. All right. So hopefully this helped out. I'm gonna stop my sharing, and so Caleb, I'm gonna see if you can share your Desmos window, and then I'll let you all collaborate. So I'm gonna jump over to the other breakout room and see how they're doing. Hello. How's everybody doing? Medium? Medium, yeah, okay. These ones are tough, right? These are challenging problems. So how are you all sharing your work here?
We're just kind of doing them on our own and then like asking questions in the chat.
And then like verbally. Let's see if I can see the chat. Okay. Yeah, I can't see your chat that you had before, so I don't have access to that. But so one thing that I was showing to the other group was we can actually do some of this in Desmos. So if I share, I know we're sort of hesitant to adapt this, but you know, if you wanted to sort of type out your answer, you know, and actually share what your answer is with somebody else, this is, I think, a pretty reasonable way to do that. So is this what you all got for part A?
I was still working on part A.
Part A, okay. Sam, Sophia?
So for part A, did you do the product rule and then the chain rule?
So you could do product rule and chain rule, but you're saying because this is 4 times some function.
Yeah, I was confused about how to do this one.
So with this 4, we could do product rule, but we don't have to. We have another rule that's the constant multiple rule that says that 4 just gets to come along for free. And then we're going to multiply by the derivative of this function right here.
Oh, okay.
So this is the answer down below, but I can show you my sort of stream of consciousness thinking through this problem. So if I'm going to take the derivative, the first thing that I'm going to do is I observe that this 4 is a constant and it gets to come along for free. So it's going to be really, this is going to be 4 times the derivative of the rest of this stuff. So I don't even have to really think about, right? I don't even really have to think about this 4. I know it just gets to come along for free. And then I'm going to think about the derivative of this function over here, which is chain rule. Okay. So the next thing that I'm going to do when I'm taking the derivative of this, I don't actually want to do the square root. I want to view the square root as the 1/2 power. Okay, so what I'm thinking about is taking the derivative of this right here, right? So the square root, I rewrite it to the 1/2 power. And for the moment, I'm just going to ignore what's on the inside, right? So I have this something, right? So it's whatever it is to the 1/2 power. And what I'm going to do to take that derivative is I'm going to use power rule. So we get down here, we're going to have 4 times 1/2 of, something raised to the negative 1/2 power. Does that make sense so far? Okay, so this is the derivative of my outside function. Now, the something, right, that we were taking the square root of is really this, right? So this is our f prime of g of x, right? This is the first part of our chain rule. So I'm just leaving this alone. I don't even actually care what this is. But I know that eventually I do care because I have to multiply by the derivative of that same something on the outside. Okay, so as I'm thinking through this problem, this is my sort of how my brain is working. I'm saying it's 4, that came down for free. The derivative of our outside function, and then I left that inside function alone. I'm going to multiply by the derivative of my inside function. And now this piece over here, I can just take the derivative of each part separately, right? So derivative of r to the 6th is 6r to the 5th. That's our power rule. And then derivative of 2e to the r is just the same 2e to the r, right? And then we see this should be the same down here, okay? Now, Desmos is really nice. So what I can do is if I give it a function like this one, I can ask for the graph of the derivative, and then I can check that against my formula that I created. Okay, so if I want to sort of check my answer using Desmos, this is a nice way to do that. And so we can verify that, in fact, these two are really the same, right? So Desmos graph and then the formula that I plugged in appear to be the same graph.
So if you multiplied the 4 times the 1/2, would that change the graph? Like if you simplified that to 2, would that change it at all?
It does not. No. So I left it expanded out like that on purpose, just so we could see the different pieces working together. But if you wanted to simplify, you could simplify it to 2.
Would Desmos accept either way or one or the other?
You mean WebWork? Yeah, yeah. So WebWork will accept either. So if you put this into WebWork and you put 4 times 1/2, it would accept that, whether you put that or 2. Yep. Okay. Does this sort of help break down the pieces a little bit more? So try this out if you want to share, right? So I know sometimes we just, hold paper up to the screen or something like that, but this is also a reasonable option to share with everything typeset out. So if one of you want to take over with the screen share, you could bring up Desmos, and then, you could just type in that sidebar if you wanted to share what your answer was. Okay. All right, other questions so far? Things seem like they're okay. Sam's pretty quiet over there, but Sam, are you doing okay? Gonna give us a thumbs up or? All right, perfect. Okay, I'm gonna jump back over to the other room and see how they're doing over there.
I have no
All
idea.
right. All right, do we like this typesetting method? Is this?
No, I think the whiteboard would be more helpful.
Okay, so we can all draw on this if you wanted to.
Oh, I just did.
So you can draw on this, right? So if you wanted to use the normal text feature, right? So you could do, you could write it out like this, right? So I'll just stop here. But see how I put some text on the screen?
Mm-hmm.
So you could use the normal whiteboard feature. So you could write all over this and ask questions. So Bella, the whiteboard that I use is so I have a Apple Pencil as a stylus that I'm using.
Oh, yeah.
So I
But
think
didn't we use one before, like in our breakout rooms? Like, how do we get back to that?
that's what this is. That's what you're doing right now.
Oh.
So you can click annotate just like you would. So on any screen share, like the whiteboard that we had before was just a screen share with a white screen in the background. But the Desmos graph over here on the right kind of acts as a whiteboard type deal as well. And so whoever's controlling Desmos, you can click that wrench on the right-hand side and you could hide the axes if you wanted to. So that was just totally blank. All right, so let's check in and see what we got here. So part B is over here. We're taking the derivative. So you set up your framework for product rule first times derivative. So this is not quite right.
This one, the sign.
Yeah, so let's leave it as it is because I think you're okay. So, but you got stuff in the wrong place. So this is F, and this is our G, right? So this should be F, and then this should be G prime, right? And then this should be G, and this should be F prime.
Oh yeah.
Oh.
So it seems like what you have. So let me change the color here. So this is F prime, right?
Yeah.
And then this is really this is G prime. So I think what you should do is swap these two.
I don't know. Can you copy and paste this out?
Yeah, you can command X will cut it out. So you can cut that. Yep. And then you want to hit command, right? So do you know the shortcuts like Control V? Are you on a Mac or are you on a PC?
I'm on PC. Okay,
so you would do Control X or Control V. Control X will do cut and Control V will be paste.
What about, wouldn't I have to copy it?
You will cutting when you do Control X, it cuts it out of there. And then it will, so it's a copy and a deletion at the same time.
So would I just
highlight it and then hit Control X. And now go over to the other spot and hit Control V.
It's not working? There we go.
There you go. right? And so then the other one would be the so you'd want right, cosine of v squared times 2b. Yeah. Yeah. So this one. So
How would we do the derivative of e to the 4y on this one down here?
So that one's gonna be a chain rule again, right? So so your outside function is e to the x, and your inside function is 4y.
So would it just be e to the
E to the 4y times 4.
Yeah. Yep. Exactly right, Bill.
yeah.
Yep. So this one's also good. Okay. All right. So for me personally, when I'm looking at this stuff, I like, I know only one person sort of gets to type into the Desmos graph, which is a little bit unfortunate, but I think that's a lot easier to read than if we were to try to write out like something over here. Right, so if I were to try to write out e to the 4y plus 1, but I think this looks pretty tough. Anyways, how does this feel? How does the math feel?
Pretty good.
Pretty good.
Okay, yeah.
Amber, Luke?
Yeah, it's good.
No, it seems like you're doing okay with it.
Mm-hmm.
Yeah. All right. All right. Keep going, and then I'll jump back to the other group, and I'll jump back here. All right. Are we doing it?
We're trying to. It just won't let me get the derivative of it, so I'm confused.
So it won't let you take the derivative of this? Type h prime of x. Okay, so you know what's happening? Yeah, so this is the derivative. Yeah.
So why is h prime of x the derivative of h of y? Like if
So that's a Desmos thing. So Desmos uses x and y. It recognizes x as values along the x-axis, and it recognizes y as values along the y-axis like this, right? So this is y. So it natively understands that whenever you write x, it's thinking that your input is x, right? So if you don't specify something in here, it wants you, if you're just saying, I want to see the graph, you need to tell it that these are your inputs. And so it's recognizing this x as your input. And so I think, using y here is causing a little bit of trouble. But I think this will be okay. This should work out. So how about this derivative?
Oh.
So are you doing the quotient rule and then the chain rule?
That's what I would do, yeah. Quotient rule, then chain rule. So who's typing in this?
Me.
Emily?
Yeah.
So do you want to do the framework setup for quotient rule? Yeah. So for me, this is really super helpful, right? So then what I can go through and I can just sort of figure out what's going to have to go into each of these spots here. And so as we're going along, right? So 3 of these spots, you're already good, right? So this one, and this one, right? You just have to copy stuff down. Yeah. That's going to be your top function. Low D high minus high. Yeah, so there's 2 derivatives, right? So now in each of these spots, you're going to have to think about, hey, what's the derivative of cosine of 10y? And then what's the derivative of e to the 4y plus 1?
And then that's where we would use chain rule.
That's right, yep. So any ideas here? So that's right, but it's in the wrong spot. So you have the correct derivative there, but yeah, it should go in the other spot. So it's low, and then derivative of low D high, right, is going to be in that spot. Then in that spot, you're going to put the derivative of the denominator. So you're backing off on it. So talk to us. Tell us what you're thinking here. So you were going. Well, I wouldn't have stopped typing if I were you. I think what you were doing was good.
Right.
Yes, it's gonna be e to the. Yep. So that's the derivative of your outside function, and now you're gonna have to use chain rule. Right. So the 1 goes away from the derivative of a constant, but now your inside function for this part is 4y. So you're going to multiply by the derivative of 4y, which is, yeah, exactly right. Yeah. And so that should be good. Okay. So go out to the front of your equation and type like, I don't know, yeah, q of x or something, or you're going to say q of y equals. Okay. Now hide that. And on another line, type q of x. And it's good, right? Yeah. Okay. So the problem that you're running into is when we have these weird variables that the book throws at us, we're not always, Desmos doesn't always like that. So it wants you to default to that x. Okay, so I'm going to bring everybody back together. So here you should see the warning to go back to the main session. So we'll bring everybody back together and talk through this. All right, so we're coming back. So this was a little bit challenging today so far. I mean, trying to share those derivatives I thought was challenging, but I was pretty pleased with how that Desmos thing went. I don't know about everybody else, but from my perspective, I thought it went okay. What do y'all think? Yeah, it was okay. I mean, we're making the best of it over here. So, so with our last couple minutes, I just want to go through one last thing for us. So in the homework, you're going to see a you're going to see a new type of function pop up, and I just want to make sure to touch on that. And so the function that you're going to start seeing is natural log. Okay, so we want to figure out in a couple minutes here, right? So what is the derivative of natural log of x? Okay. All right. So the derivative of natural log. I'm going to put this up here at the top. So this, the key to this problem or solving this problem is figuring out that if I have some function, I think our book calls it, say, g of x. If g of x equals the natural log of x, that's the same thing as saying x equals e to the g of x. Okay, so this might be a strange thing, but if you recall that e to the x and natural log of x are inverse functions, and so this is what we get when we have two inverse functions, right? So they sort of undo each other, and so this is our property of natural log. So in order to take this derivative, what we're going to do is we're actually going to look at it this way. Okay. And so I'm going to go through what's highlighted over here in yellow and then see if we can figure out what the derivative is. So when we take this derivative, whenever we see a g prime pop up, we're gonna recognize that as the derivative of natural log. Okay, so we're going to start here with x equals e to the g of x. And I'm going to take the derivative of both sides of this thing, right? So I'm going to take the derivative of x, and I'm going to take the derivative of e to the g of x. So the derivative of x, when I take that, derivative of x is just 1. And the derivative of e to the g of x is, well, e to the g of x times the derivative of our inside function. We're going to go ahead and use chain rule here and recognize this to say, okay, so using chain rule, I get this is e to the g of x times g prime of x. And so g prime is actually the derivative of natural log. So what I'll do is I'm going to divide this over to the other side. Okay, so I'm going to take this and I'm going to bring it over to the other side by dividing. Okay, so we get g prime of x is 1 over e to the g of x. And then one final step here, we have this in yellow, right? So recognizing e to the g of x, right? That's the same as x. So we have this here. Okay, so g prime of x is equal to 1 over x. All right, so what this happens, right? So g prime, that's the derivative of natural log, and it gives us this new rule to tack on to our rule list, right? So derivative of natural log of x is equal to 1 over x. Okay. And so I am over by 2 minutes, but just to do something really quickly here for you. So if we did an example with natural log, so we had this, say, derivative of natural log of sine x, something like this. So this is the type of problem that's going to be in the chain rule section on WebWork. So when we take this derivative, we are going to look at our outside function is natural log. So when I take the derivative of that, it's going to be 1 over our inside function, right, which ends up being sine x. And then we're going to multiply by the derivative of sine x, which is cosine x, right? So this would be a chain rule example where this piece is our f prime of g of x. Then this piece over here is our g prime of x. Okay. So yeah, I just wanted to capture this one on a recording. So I know we're going fast, but in a few, probably in an hour or so here, I'll post this up to YouTube so you can go back and watch the recording here as well. All right, so with those of us who are still hanging in there, any questions for me before we sign off for the day?
Is the inverse trig web work still due on Sunday?
So it is currently still due on Sunday, yeah. So we'll go over that stuff on Friday. So what we just did right here with the natural log is in the same section as the inverse trig stuff. But if we need more time, we can push it back. Right. So pretty much for the rest of the semester, due dates are all going to be pretty flexible. So if we ever need more time, I'm never going to say no to giving you more time if you need it. Right. So try it out, and then so even this past one, the homeworks that were due this past weekend, I pushed the due dates back on those. A lot of people are requesting more time, so I'm happy to be flexible and accommodating and give more time or attempts as needed on things. Okay. Other questions, comments, concerns? All right, well, we'll see you back here on Friday, same time. And so we'll pick up with 2.6, right? And so as Emily suggested, we're going to look at the inverse trig functions and how we can figure out what those derivatives are. Okay. All right. So I'll see you all then. Stay safe. Stay healthy. See you then.
Catch you later.